Hey all, I want to show you C++ development with Pixi. What we can do is do a Pixi init of a workspace. Any name works, but workspace is my name. If I move into the workspace, I can do Pixi add, and then I can add a CMake, I can add compilers, I can add Ninja, I can add boost-cpp, for instance. You name it. And that will do the installation of compilers. In this environment, I now have CMake available. So if I do Pixi run CMake, you can see that it just installed CMake. If you don't trust me, you can do which CMake, and it will tell you that it is directly installed into this virtual environment, so into the environment that is close to my workspace. So I don't have CMake installed locally on my system. So if I now open this workspace in an editor, you can see that the Pixi toml file that it created is containing all the dependencies that I have specified just now, and it also created a log file. In this log file I have all the specific dependencies, and specifically which version, all logged down. So if I want to recreate this later, that works perfectly. If I also want to add like Windows 64 for instance, or Linux, yeah, thank you cloud, I can do the same thing again. So let's open a terminal and do Pixi log. Then Windows will also be added to my log file, and I can make sure that everything also works on Windows. So it added some Windows specific tools that you don't need on Windows. Oh, and on Linux, of course. So what is next? So you often want to make like a main.cpp file. You want to make a cmake lists.txt. I don't need you for that. What we can do in those files, we can adding some code. I will just copy it simply from a little example that I prepared, and in here we'll be using boost string. Yeah, just some simple boost code to parse this string and output it to my terminal. And I want to add a little cmake list file where I link boost directly to my executable. I don't need you now. So we can again use Pixi to run these commands. So I can do Pixi run what is configure cmake -b build, and then it will create me this this build folder, as you would expect. This is pretty cumbersome that I have to do this every time. So in Pixi we can do tasks, which we don't have any yet, but I will add a few tasks from my prepared example where you can have the configure, build, and test tasks directly into your Pixi toml. Let's make that a little less big. What you can see is that we have a configure task, which kind of what I just run, a build task to build the stuff, and a test task that you can run on these environments. The interesting thing is that we also have a depends on. So if we want to run the configure, build depends on configure. So if we run build, it will first run configure, and if we run test, it will first run build. So it will run that. Let me quickly also add the testing requirements to my cmake list. And then we can try this again. So if I now run Pixi run test, it will start configuring, it will start building, and it ran the test. Now that was pretty cool. So what do we have now here? We have in the build folder, we have cppcon, because my example project was named cppcon. So I'll do Pixi run cpp dot build /cppcon, and you'll see that it did that hello world thing from the main, and that's basically all you have to do to set it up to get it working. And everything that we need to do now is like make sure that we test this in CI. So what I can do is I can add another folder called, not in there, I can add another folder in my main workspace called .github, and in there I can make another folder workflows, and in there I make a file ci.yaml. Perfect. And what it does, it allows me to set up CI and I'm again going to copy that from the example. So what you will see if you set up CI with Pixi, you can simply make one job. That job you can run over all the OSs that you want to test on. In there you have to check it out, of course, which is always the case if you want to run your own code in a GitHub action. Then you use setup Pixi. This will install Pixi for you, but it will also install the environment for you. And then Pixi can run these things directly. We didn't make this in this example, but this will do the exact same thing as you did locally. So let's do that again. Pixi run test. It will do for us the configure step. It will do the build step, and it will do the test step to check out that this executable is runnable. One of one test. It will have made that cppcon binary in the build folder for you. I cannot quickly make this example on CI for you, but let me show you the example in my little project that I prepared. So here you can see the same thing I did in the minimal example. All the files are there, so the Pixi toml is the same as what we just created. What's also the same is that workflow file. I also tested how to do this without Pixi, but what you can see is that I have the same commands in here. And if you then go to my main and you go to the CI, so let's look at some details. So you can see that on Ubuntu, this has ran. It has set up my environment in just a few seconds. You can see what's installed in there. And then it runs that test, which is the configure, the build step, and then the test step with ctest. And this runs on all platforms because I don't need to do any different configuration for Windows. All the same things run. So it did the configure, it did the build, and it did the test. I hope this was informative for you, and hope you will try out Pixi to see if this works for you. Thank you.